Hello. Hello students, welcome to the session. So in this session we are going to discuss the problems of GATE 2024 of EC branch, right? So regarding the difficulty level of the question paper, based on the feedback from the students, I would rate the paper as moderate paper, right? So we have collected as many memory based questions from our students. So we have not included questions with complete data. Okay, so we have we have collected as many number of problems from our students. So we will start with the first problem. Look at the first problem. What is he asking to do? Oh, he is asking you to calculate. He has given a two-port network and he is asking you to calculate the parameter y21, right? So this is a two-port network. So therefore, how do you calculate y21? So we know that the equation, y parameter equation, I2 is equal to y21 v1 plus y22 v2, right? So from this, what is y21? What is y21? Y21 is equal to I2 divided by v1, I2 divided by v1 when v2 is equal to 0, right? When v2 is equal to 0. So V2 is equal to 0 in the sense that the second port is short circuited, right? The second port is short circuited. So therefore, I am going to short circuit the second port, right? Second port. So what happens to the voltage at this particular node? So look at this one. This is grounded, right? This is grounded. So this is the potential at this particular node is 0 volt. So therefore, this 0 volt will appear directly at this particular node, right? This 0 volt will appear directly at this particular node. So therefore, this is 0 volt, right? So therefore, what is I1? What is I1 from this particular in flowing through this particular branch? So I1 is equal to V1 by 2. Right, I1 is equal to V1 by 2, right? So what we require is the ratio of I2 and V1, right? Ratio of I2 by V1. So therefore, look at this one. What is this current? So this is I1, okay, this is I1 and this is I2, right? This is I1 and this is I2. So therefore, what will be this current? This current will be equal to I1 plus I2, right? I1 plus I2, right? So based on the current direction, I am going to mark the polarity. So therefore, this is plus and minus, right? Plus and minus. So therefore, what I'll do is I'll write KVL in this particular loop, right? I'll write KVL in this particular loop. So what is it that I get? So look at this one. When I write KVL in this particular loop, so this is nothing but 0, 0 minus of I1 plus I2. So when you write KVL around this particular loop, what do you get here? So this is equal to 0 minus of I1 plus I2 into 4, right? And you are moving from lower potential to higher potential. So there is a voltage rise. So therefore 8 V1 is equal to 0. Right, 8 V1 equal to 0. Also we have got this equation. So this I'll call it as equation number 1, right? Equation number 1. So therefore from this equation we have I1 is equal to V1 by 2, right? So therefore substitute, that is what we require is the relationship between I2 and V1. So we have to eliminate the variable I1, right? So therefore I1, so when you eliminate the variable I1, so you can simplify this equation as I1 plus I2 into 4 equal to 8 V1, right? So therefore this is 8 2 times, right? So this is 2. So therefore I1 is nothing but V1 by 2. Right, I1 is nothing but V1 by 2. So therefore, so V1 by 2 plus I2 is equal to 2 V1, right? So I'll send V1 to the other side, V1 terms on one side. So therefore, I2 is equal to 2 V1 minus 0.5 V1, right? 0.5 V1. So therefore, I2 by V1. So this is what we require, right? So I2 by V1. I2 by V1 is equal to 2 minus 0.5 is nothing but 1.50 mho, right? So he is asking you to find the admittance. So therefore, so this is nothing but mho. So this is nothing but Y21. So the answer to the first question is 1.5 mho, right? So 1.5 mho. So the answer to this particular question is 1.5 mho, right? So this is question from network theory. So in fact, this paper, looking at the memory based question, this question paper is a good mix of easy and difficult questions, right? Easy questions, they have asked easy questions as well as difficult questions. So difficult questions are basically from SSD, right, solid state devices. So they have relatively asked simpler questions from network theory, right, network theory. So all the questions from network theory are very simple, right? So let us look at the next question. So look at this one, look at the next question. For the given causal LTI system, okay, for the given causal LTI system, transfer function h of z, okay, for the given causal LTI system, transfer function h of z is given. So he is asking you to find the correct statement. So this is essentially a multiple select question. So you have to select all the correct answers, right? So tell me, look at the first option. What is the first option? System is minimum phase, right? When do you say that the system is minimum phase? If all the zeros and poles are within the unit circle, right? So therefore first you have to calculate the position of zeros. Okay, you have to calculate the position of zeros and poles, right? So therefore look at the denominator, look at the characteristic equation, look at the roots of the characteristic equation is nothing but, so you have poles at, so you have your poles at z is equal to plus or minus 1 by 3, so which are well within the circle, right? So the poles are within the circle, right, within the unit circle, right? So therefore this is nothing but the location of poles. Now location of zeros, so location of zeros, so therefore 2z square, so roots of the numerator polynomial 2z square plus 3 is equal to 0, so therefore z is equal to so this is equal to plus or minus j into square root of 3 by 2, right? So this is nothing but square root of 3 by 2. So square root of 3 by 2 is something around 1.22, right, 1.22. So therefore square root of 1.5 is around 1.22. So therefore zeros, look at the zeros, you have two zeros which, so this is nothing but it is outside the unit circle, right? So for a system to be minimum phase, both zeros and poles should be within the unit circle. So you can clearly see that zeros are outside the unit circle. So therefore the first option is incorrect, right? The first option is incorrect. So the first option is incorrect, right? Now final value of the impulse response, final value of the impulse response is, so how do you calculate the final value? So final value of impulse response, so h of infinity is equal to limit z tending to 1 minus z inverse into h of z, right, into h of z. So therefore, or z minus 1 into h of z, right? So any equation that you like to apply here, okay? So look at this one. So limit z tending to 1, right, limit z tending to 1 minus z inverse into h of z is nothing but 2z square plus 3 divided by z plus 3 into z minus 3, right? So you can clearly see that when you apply this limit, this will result in 0, right? So therefore the final value of the impulse response, the final value of the impulse response is 0. So therefore the second option is correct, right? The second option is correct. Now look at the third option. Initial value of the impulse response is 2, right? Initial value of the impulse response is 2. So let us calculate the initial value. So apply initial value theorem. So limit z tends to infinity, right, h of z, right, limit h tends to infinity h of z. So therefore look at this one, this is equal to limit z tends to infinity. So what is your h of z? H of z is equal to 2z square plus 3 divided by z plus 1 by 3 into z minus 1 by 3, right? So clearly if you take z square common from the numerator and denominator, what are you left with? Limit z tends to infinity, z square into 2 plus 3 by z square, and here you can take z common from each of these terms. So therefore z into 1 plus 1 by 3 z into so this z. So you can also take z common from the second term. So therefore this becomes z square. So therefore 1 minus 1 by 3 z, right? So therefore z square and z square will cancel. So apply this limit. So therefore what is it that you get? So this is nothing but this term becomes 0, okay? This term becomes 0, this term becomes 0, and this term becomes 0. So 2 by 1, which is nothing but 2, right? So therefore you have calculated the final value as well as the initial value. So what is it that you get? So the second and third options B and C are correct. Okay, options B and C are correct, right? And what about the last option, system is stable? So look at this one. So we have already calculated the final value, right? Also you can clearly see that the poles are within the unit circle, and he has clearly mentioned that the system is a causal LTI system. So therefore what happens? So the ROC of this one will be greater than the outermost pole. So outermost pole, so this is the ROC of the transfer function. You can clearly see that the ROC includes unit circle, so therefore the system is also stable, right? The system is also stable. So the answer to this question, B, C and D, right? All the three options are correct. So this is a multiple select question. So if you want to get the specified marks, you have to select all the correct answers, right? So this is a multiple select question, right? Now let us move on to the next question. Look at the next question. Read the question carefully. Causal and stable LTI system with impulse response h of t produces y of t, right, for input x of t. So therefore we know if x of t is the input to a causal LTI system, so how do you get the output? So this is nothing but the convolution of input and the impulse response gives you the output, right? So what is he saying? A signal x of 0.5 t is applied to another causal and stable LTI system with impulse response h of 0.5 t, right? So output y of t. He is asking you to calculate output y of t when the input to the LTI system. So the input to the LTI system, now you are applying x of 0.5 t and the impulse response is h of 0.5 t, right? So therefore we already know this property, that is h of at convolved x of at is equal to 1 by magnitude of a y of at, right? So you can clearly see that a in this case is nothing but 0.5, right? So therefore x of 0.5 t convolved h of 0.5 t is equal to 1 by magnitude of 0.5, right? So into y of 0.5 t, right? So therefore 1 by 0.5 is nothing but 2, so 2 into y of 0.5 t, right? So therefore the answer to this question is nothing but 2 into y of 0.5 t, right? So this is a multiple choice question, so you have options, so this is a correct answer, right? This is a correct answer. Okay, so you can clearly see the questions from signals and systems are also very simple, right? So look at the next question. So this is a tricky question, so look at this one. Most of them have solved this incorrectly, so listen to this question very carefully. He has given that y of t is equal to dft of dft of dft of dft of x of n, okay, and a sequence is also given to you, okay, and a sequence is also given to you. X of n is equal to 1 comma 0 comma 2 comma 1. I am not sure about the sequence, okay. So look at this one, 1 comma 0 comma. So the first we are in need of only this first sample. The other three samples we are not very sure. The first sample is sure, okay. So the first sample is 1, the value of the first sample is 1, right? So he's asking you to calculate the y of 0, right? So this is y of n. So what you have to calculate is the dft of y of n, right? Dft of y of n, and substitute k is equal to 0. So capital Y of 0, okay. So this is what is asking to calculate, okay. This is what we have to calculate, right? Now look at this one, y of n is equal to dft of dft of dft of dft of x of n, right? So look at this one. I am going to apply here duality property, that is x of n. So if x of n and x of k forms a DFT pair, so what is duality property? So DFT of capital X of n is equal to capital X of n is equal to capital N into small x of minus k, right? So therefore this is nothing but capital. So DFT of x of n, so DFT of x of n is nothing but x of k, right? Now what is DFT of x of k, which we have already calculated? So this is nothing but n into x of minus k, right? So DFT of n into x of minus k, right, dft. So this is nothing but x of k, x of dft of x of k we have already calculated, n into x of minus k, right. So therefore now what is this one? So dft of n into, so dft of, so what is, tell me the dft of n into x of minus n. So n into x of minus n, so we know that it satisfies linearity property. So therefore if a signal is multiplied by n, so therefore the signal in the transform domain also gets multiplied by the same scaling factor. So if it is n, this will also be capital N. So this is equal to, so which property? This is nothing but time reversal property. So therefore x of minus n is equal to x of minus k, right, x of minus k, right. So therefore this is nothing but x of n into x of minus k, right. Now you have to calculate the dft of this one. So therefore n into capital X of minus n. So the dft of this one, again now you have to apply the duality property. So therefore this becomes n into x of, so here you already have a minus n, so therefore this will be minus of minus k, so therefore this will be k, right. So therefore this is nothing but n square into x of k, right. So this is nothing but, so this is nothing but the dft, this is nothing but the dft of so this is your y of n, right, this is your y of n. So dft of y of n is nothing but n square, so y of k is equal to n square into x of k, right. So all you have to substitute is k is equal to 0 into this equation. So k equal to 0, substitute k equal to 0 into this equation. So n square into x of 0. So therefore n is nothing but the number of samples in this particular sequence is 4, right. So therefore this is nothing but 4, okay. So it is a periodic sequence with period 4. So therefore 16 into x of 0. So what is the first sample? The first sample is nothing but 1. So therefore 16 into 1 is nothing but 16, right. 16 into 1 is nothing but 16, right. So therefore, so that's the reason why we told you that the sequence, we are not sure about the sequence, we are confirmed about the first sample, right. The first sample is definitely 1, we are not sure about the remaining sequence, right. So in this particular question we need only the first sample, right. So therefore 16 into 1 is equal to 16, okay. So this is a bit tricky question from signals, okay. Other than this remaining questions are straightforward, right. So look at the next question. So this is very simple, right. So look at this one, 40 dB per decade. So this is a question from controlled system. So look at this one, 40 dB per decade. So we know that 20 dB per decade is equivalent to 20 dB per decade is equivalent to 6 dB per octave, right, 6 dB per octave, right. So he is asking you to find the equivalent of 40 dB per decade. So 40 dB, 20 dB per equivalent of 20 dB per decade is 6 dB per octave. So 40 dB per decade is simply 12 dB per octave, right. So 12 dB per octave, right. So this is nothing but this problem. So the answer is 12 dB, option A, right. Option A is the correct answer, right. Now look at the next question. Look at the next question. You can see the block diagram, okay. You have a unity feedback system, g of s is given, r of t is equal to u of t, and he is asking you to calculate the steady state error, right. Look at all the options, limit t tends to infinity, e of t is nothing but, so this is nothing but e of s. So therefore inverse Laplace of e of s is nothing but e of t, right. So he is essentially asking you to calculate the steady state error, right. He is asking you to calculate the steady state error, okay. Now look at all the options. Now he is asking you to calculate the steady state error for step input, right. So step input, so normally what students do is, since they have asked for step input, so they'll directly apply this one, that is a by 1 plus kp, where position error constant kp is equal to limit s tends to 0 g of s, right. Since the given function is of type 1, right. So look at this one, this is a type 1 system. So therefore limit s tends to 0, g of s will be equal to infinity. So therefore steady state error will be a by 1 plus infinity. So therefore this will be equal to 0, right. So if you have selected this option, then your answer is wrong, right. Your answer is wrong, right. Listen, steady state error, you can apply the steady state error analysis only for a stable system, right? Only for a stable system. So listen, the hint for checking whether the given system is stable or unstable. So look at this one, look at the fourth option, not exist because E of t is oscillatory, right? Does not exist, that is steady state error. So if there is no stable output, there is no question of finding steady state error, right? So you can find steady state error only and only if you have a stable output, right? So therefore look at this one, you have to check whether the given system is stable or unstable, right? So therefore how do you check that? So you can use RH criteria. So look at this one, what is the characteristic equation that you get? So s into this is nothing but s square plus 3s plus 2, right? S square plus 3s plus 2 plus 6, right? So is equal to 0. This is a characteristic equation. So s cube plus 3s square plus 2s plus 6 is equal to 0, right? So you can clearly see the internal product is equal to the external product. So 6 is equal to 6. So therefore the given system is marginally stable, right? So look at this one, the output of the system does not converge to a finite and stable value, right? So therefore look at this one, the system is oscillatory, right? The system is oscillatory. So therefore you don't have a final stable value, right? So therefore you can't find the steady state error for this particular system. So therefore the correct answer is D, right? The correct answer is D, right? So the questions from control systems are bit tricky, okay? The questions from control systems are bit tricky. The questions from network theory are very simple, right? So look at the next question. So what is he asking? Given g of s, the open loop transfer function. So g of s is given to you. So k by s plus 1 into s plus 2 into s plus 3 is given, okay? So find k so that the impulse response of a closed loop system decays faster than e raised to minus t. Okay, so this is basically a question based on the relative stability, right? So e raised to minus t. So e raised to minus t in the sense that, so what is the Laplace transform of e raised to minus t u of t? This is nothing but 1 by s plus 1, right? 1 by s plus 1. So therefore look at this one, you have to find the relative stability of the system about s equal to minus 1, right? S equal to minus 1, right? So therefore what I am going to do is, so we know the method of finding the relative stability of a system. So therefore what I am going to do is, so s plus 1 I'll take it as z, right? S plus 1 I'll take it as z. So therefore look at this one, I'll send this 1 to the other side. So s is equal to z minus 1. What I'm going to do is, I'll substitute s as z minus 1 into this equation. So g of s is now replaced with z. So therefore it becomes g of z. So therefore k by, look at this one, s is now replaced with, or s plus 1 is simply z. So therefore this is z. So s is simply replaced with z minus 1. So therefore z plus 1 into z plus 2, right? Z plus 2, right? So look at this one. So now you can easily calculate the value of k, right? Calculate the value of k using the RH criteria. So therefore look at this one, what will be the characteristic equation? The characteristic equation will be z into z square plus 3z, okay, 3z plus 2, right? 3z plus 2 plus k is equal to 0, right? So z square, z cube plus 3z square plus 2z plus k is equal to 0, right? So this is nothing but the characteristic equation, okay? This is nothing but the characteristic equation. So you can clearly see that for the system to be stable, the internal product, okay? So look at this one, apply the RH criteria, z cube, z square, z raised to 1, z raised to 0. So therefore the coefficients of, look at this one, 1, 1, 2, 3 and k, right? So therefore 6 minus k divided by 3, and this is directly copied here. So therefore for the system to be stable, k should be greater than 0, and 6 minus k by 3. So all the elements in the first column should have the same sign. So therefore 6 minus k should be positive, right? So therefore 6 So if I send this minus k to the other side, so you can clearly see that k should be greater than 0 and k should be less than 6, right? So which option satisfies this condition? You can clearly see that only option D will satisfy, right? Option D will satisfy. Okay, so this is how you solve this problem. So this is basically a problem based on relative stability. Okay, so he's asking you to find the relative stability about the point s is equal to -1, right? S is equal to -1. So look at the next question. This is a straightforward question. So this is multiple select questions. We don't have the options with us, right? So this is nothing but multiple select question. So you are asked to calculate the transfer function of this particular system, and you have to select all the corresponding options, right? So there are 4 options given to you. Okay, so 4 state space representation of different systems are given to you, so you have to select those systems with the same transfer function, right? So how do you calculate the transfer function? Transfer function is equal to C into Si minus A whole inverse into B, right? So look at this one. This is nothing but matrix A, state matrix, right? This is the input matrix and this is the output matrix, right? This is nothing but C. Okay, now tell me what is C? C is nothing but -2, -5, right? C is nothing but -2, -5, and this is nothing but Si minus A. So therefore S, okay, S minus A, this is 0, so therefore minus A, this is -1, and this is 2, and this is S plus 3, right? S plus 3 whole inverse multiplied by what is B? B is nothing but 0 and 1, right? So therefore this is nothing but -2 -5. Calculate the inverse. Inverse is nothing but determinant of this one is nothing but S into S plus 3 plus 2, so therefore S square plus 3S plus 2, right? So what is the inverse? Inverse of a 2 by 2 matrix. So therefore D, A, B, C, D. Suppose the entries are A, B, C, D. So therefore this is D and this is A, and this becomes minus B and minus C. So therefore 1 and -2. So this is nothing but the inverse, right? So when you calculate this one, what do you get? So look at this one. S plus 3 into 0 is 0, right? 1 into 1 is nothing but 1 into 1 is nothing but this is 2 by 2. So this is 2 by 1. So therefore the resultant matrix will be 2 by 1, right? So S plus 3 into 0 is 0. 1 into 1 is 1. -2 into 0 plus S into 1 is nothing but, so this is S, right? This is S. Okay. So this is nothing but the simplification, right? So denominator is nothing but S square plus 3S plus 2, right? So one more way. So look at this one. This is nothing but when you multiply this one, so -2 minus 5S divided by S square plus 3S plus 2, right? This is nothing but the transfer function of the given system, right? Now tell me, directly from the state matrix you can also write this one, right? So this is nothing but the looking at the second row, you can directly write the characteristic equation. So look at this one. This is nothing but S square plus 3S plus 2, right? How do you write this one? How do you write these terms in the denominator? So this is nothing but the second row of the state matrix. Okay, this is nothing but the second row of the state matrix with inverted sign, right? With inverted sign. So you have to check the transfer function of each of the given system in the options, right? So this is a bit time consuming, right? This is a bit time consuming because you have to check the transfer function of each of the systems. So therefore this is a simple question but a little bit time consuming, right? So this is how you calculate the transfer function, right? Now let us move on to the next problem. Calculate the value of Ix from the circuit shown below. Calculate the value of Ix from the circuit shown below. Okay, so look at this one. You can clearly see that two nodes are connected by a voltage source. Okay, a dependent voltage source. Two nodes are connected by a dependent voltage source. Whenever you have this situation, the only method, okay, to analyze the circuit is nothing but supernode analysis, right? Supernode analysis. So look at this one. What happens here when you apply KCL? When you apply supernode, so assume this as the supernode, right? Assume this as a super node and apply KCL at this particular node. You can clearly see that 5 milliamperes is flowing into the node, right? 5 milliamperes is flowing into the node. So therefore this is nothing but minus 5 milli, right? And this, the current is leaving, so therefore this is nothing but I naught, right? And here the current is, if this is 2 milliamperes, so this will also be 2 milliamperes, so therefore this is 2 milli, right? And this is nothing but Ix, right? This is nothing but Ix. So therefore I have considered this as a super node because two nodes are connected by a dependent voltage source. Okay, so what I am going to do here is I will assume all the currents, so I naught and Ix, I will assume these currents to be in milliamperes, right? So therefore if I naught and Ix are also in milliamperes, you can take milliamperes common from each of these term and you can send it to the other side, right? So in that case, so under the assumption that I naught and Ix are in milliamperes, so therefore I am taking milliamperes common from each of these terms and sending it to the other side. So what is the resultant equation that you get? Minus 5 plus 2 is something but minus 3. Minus 3 I'll send it to the other side, so therefore I naught plus Ix is equal to 3, right? So this is nothing but equation number 1, right? This is nothing but equation number 1, right? So again, now what I'm going to do is what I require to find is Ix, so all I have to calculate is I naught, okay? I naught. So once we get I naught, you can easily calculate the value of Ix, right? So in order to calculate, in this equation you have two unknowns, okay? We have one equation and two unknowns, so therefore we are in need of one more equation. So what I am going to do is I'll write the KVL around this particular loop, right? Around this particular loop. So since current is flowing downwards, the direction of this current is already given to you, so I'll mark the polarities plus minus, right? So what I'm going to do is I'll write KVL. I'll start from this node, okay? I'll start from this node. I will write the KVL around this loop, right? Around this loop. So I'll come back to this node itself, right? So therefore look at this one. We are moving from lower potential to higher potential, so therefore there is a voltage rise, so therefore 1000 into I naught, right? 1000 into I naught. Now what about this one? This is nothing but current is flowing downwards, so therefore how should I mark the polarities? Before writing KVL, make sure that you mark polarities across every element in the loop, right? So therefore since current is flowing downwards, resistor always absorbs power, so therefore according to passive sign convention, current always flows from higher potential to lower potential, right? So therefore I have marked the polarities based on the current direction, right? So look at this one. Here also current is flowing downwards, so therefore based on the current flow I have marked the polarities plus minus, right? So therefore the first the drop across the first element is nothing but 1000 I naught. So what about this one? This is nothing but minus Ix into 1k, right? Minus Ix into, because you are moving from higher potential to lower potential, voltage drops, so therefore minus. Now again look at this one, you are moving from lower potential to higher potential, there is voltage rise, so therefore plus, right? So what is the current, what is the drop? So this is nothing but I naught into 1k is equal to 0, right? So since we have made this assumption, what did we assume? These currents I naught and Ix are assumed to be in milliamperes, right? So therefore I naught is in milliamperes, Ix is also in milliamperes. So therefore listen, I naught is in milliamperes, so milli multiplied by 1000 becomes 1, right? So therefore this becomes I naught, right? Minus Ix is in milliamperes, here you have 1k, so milli into kilo becomes again 1, right? So therefore this becomes Ix, right? So I naught is in milli, right? Again you have 1k, so therefore this also becomes I naught, so this is equal to 0, right? So 2 I naught is equal to Ix, right? 2 I naught is equal to Ix, so therefore this is your second equation. You have two equations and two unknowns, right? So therefore eliminate I naught. So I naught, I can write it as I naught, I can write it as Ix by 2, right? Ix by 2, so therefore look at this one. So Ix plus what is I naught is nothing but Ix by 2 is equal to 3, right? So therefore 1 by 2 is nothing but 0.5 plus 1 is nothing but 1.5, Ix is equal to 3, so therefore Ix is equal to 3 by 1.5, which is nothing but 2 milliamperes, right? Because we have assumed that the Ix to be in milliamperes. So therefore 3 by 1.5 is nothing but 2. Since Ix we have assumed it in milliamperes, so the answer is 2 milliamperes, right? So therefore the answer to this question is 2 milliamperes. Okay, we don't know whether it is a numerical answer type question or MCQ. The answer is 2 milliamperes, right? The answer is 2 milliamperes, right? Now let us move on to the next problem. So this is a question from EMFT, right? This is a question from EMFT. Let us look at the question. All of you please read the question. For the given field, so two vector fields are given to you. You are asked to identify which of these fields are electrostatic fields, right? So how do you check what is the condition for an electrostatic field? So electrostatic field, we know so look at this one, del cross E bar. So we know that the electrostatic field is a conservative field, so del cross E bar is equal to 0, right? So this is how you check whether the given vector field is electrostatic field or not, right? So therefore you have two vector fields, so get me del cross F1, right? Calculate del cross F1 and similarly del cross F2, right? Del cross F1 and del cross F2. So when you calculate this one, so this is nothing but I, J, K, right? This is dou by dou X, dou by dou Y, dou by dou Z, right? So the amplitude is same for all the field components. So therefore look at this one. So this constant is fixed, so A is fixed. So therefore look at this one. What is X component? X component is nothing but A into Y, right? This is nothing but AY, this is nothing but AY, and this is nothing but AX, right? And there is no K component, so therefore this is simply 0, right? So therefore what is it that you get? So this is nothing but dou by dou Y of 0 is nothing but 0, dou by dou Z of X is nothing but 0, right? So minus J into dou by dou X of 0 is nothing but 0, dou by dou Z of Y is also 0, right? So this is J, and what is K component? Dou by dou X of AX is nothing but A, right? Minus dou by dou Y of AY is nothing but A, right? So this you can clearly see that this is 0, and this is also 0. So you can clearly see that del cross F1 is equal to 0, right? Del cross F1 is equal to 0. So therefore the given vector field satisfies the condition for the electrostatic field. So therefore F1 is a electrostatic field, right? Now what about F2? So this is an exercise to you. When you solve this one, del cross F2 will come out as a non-zero value. So therefore from this we can conclude that F1 is electrostatic but not F2. So therefore the correct answer to this question is B, right? Option B, right? So this apply the same procedure. You will find the value of del cross F2 as a non-zero value, right? So therefore the answer to this particular question is B, right? Now let us move on to the next question. So this is also a question from EMFT, right? So what is he asking? A lossless transmission line Z0 equal to 50 ohm terminated with unknown load with the magnitude of reflection coefficient is given to you, which is nothing but 0.6, right? As one moves towards the generated from the load, okay, the value of the input impedance looking towards the load, right? Value of the input impedance looking towards the load, right? So we know that the maximum value of the input impedance is nothing but the S times Z0, right? S times Z0, where S is nothing but the standing wave ratio. So how do you calculate the standing wave ratio? Standing wave ratio is nothing but 1 plus magnitude of gamma divided by 1 minus magnitude of gamma, right? So magnitude of gamma is already given to you. So this is nothing but 1 plus 0.6 divided by 1 minus 0.6 is equal to 1.6 by 0.4, which is nothing but 4, right? Which is nothing but 4. So therefore you can clearly see that the value of S is nothing but 4, the value of Z0 is nothing but 50. So therefore this is nothing but 200 ohms, right? 200 ohms. The answer to this question is 200 ohms, right? The answer to this question is 200 ohms, right? So this is fairly simple. So the questions from EMFT are also very simple, right? So EMFT and networks, the questions are straightforward, right? signals and systems also, except one or two questions. The questions were very simple, right? So he has asked a bit tricky from control systems, right? Now let us move on to the next problem. Look at the next problem. The load impedance is short circuited. Okay, ZL is equal to 0. Okay, ZL is equal to 0. He is asking you to calculate the normalized impedance at lambda by 8. Now at A, this is A, this is B, this is C, and this is D, right? A is at a distance of lambda by 8, B is at a distance of lambda by 8 plus lambda by 8. So this is nothing but lambda by 4, right? This is nothing but lambda by 4. C is at a distance of lambda by 8 plus lambda by 4, right? D is at a distance of lambda by 4 plus lambda by 4, which is nothing but lambda by, so this distance is nothing but lambda by 2, right? We know that the impedance from Smith chart, we have learned that the impedance repeats every lambda by 2 cycle, right? Every lambda by 2 cycle. So therefore the impedance at the load and at the D, at the point D should be the same, right? So load impedance is short circuited, so therefore the impedance at the point D should also be short circuit, right? Impedance at the point D should also be short circuit, so which is nothing but 0 ohms, right? So therefore from the options you can clearly see that you can eliminate option C and option D, right? So because the only in option A and B you can find the impedance at D to be 0 ohms, right? So therefore this is the first point, right? Now look at this one. At B you can clearly see that B is at a distance of lambda by 4, so therefore the impedance will invert, right? The impedance will invert, right? So impedance inverter, so lambda by 4 is a impedance inverter line, so therefore at a distance of lambda by 4 from the load the impedance will invert. So what is the inverted impedance? So load is short circuited, so therefore inverted impedance at point B will be open circuit, right? So therefore input impedance at point B should be open circuit, so therefore you find the same in options A and B, right? So obviously you have to calculate the impedance at point A, right? So point A is at a distance of lambda by 8 and lambda by 8. So what is the input impedance? Equation for input impedance of a lambda by 8 line. So Zin is nothing but Z0 into ZL plus JZ0 divided by Z0 plus JZL, right? So substitute ZL equal to 0 into this equation, you will get as 1J, right? You will get as 1J. So therefore you can clearly see that option A is the correct answer, right? Option A is the correct answer, right? So this is how you solve this particular problem. Now let us move on to the next problem. So this is a question from analog electronics. Okay, this is a question from analog electronics. So there is a mistake in this particular circuit. Actually this is a oscillator circuit, so therefore there will be a connection from the output to the non-inverting terminal, right? Non-inverting terminal. So this there is a correction in the circuit diagram. This node, the output of the feedback network, is connected to the non-inverting terminal, right? So what is he asking? He is asking you to calculate the frequency of oscillation and the relationship between R2 and R1. Okay, R2 and R1. So okay, this is R1, maybe R1 and R. Okay, he's asking you to find the relationship between R1 and R, right? So it is not R2 and R1, it is the relationship between R and R1, right? So how do you calculate this one? So first you have to take the beta network, so therefore this is nothing but the beta network, right? This is nothing but the beta network. Okay, this is nothing but the beta network. So this is V0, okay, and this is Vf. So therefore look at this one, this is the beta network or the feedback network. So what is beta? Beta is nothing but Vf by V0, right? Beta is nothing but Vf by V0. So what is Barkhausen's criteria? So A beta should be equal to 1, right? Now what is the gain of the amplifier? So which amplifier is employed here? Is it inverting amplifier or non-inverting amplifier? Clearly, you can clearly see that the input is fed to the non-inverting terminal. So therefore, this is a non-inverting amplifier, right? So therefore, this is the gain of the non-inverting amplifier is 1 plus R1 by R, right? 1 plus R1 by R. And now you have to calculate the beta, right? So beta, how do you calculate beta? Beta, I have already taught you how to calculate beta in the class when we discuss the Wien bridge oscillator, right? So therefore, look at this one. This is equal to 1 by SC. This is R, and this is 1 by SC. What I have done is I have transformed the network into S domain, right? I have transformed the network into S domain. So therefore, directly I am going to write the beta as, look at this one. How do you write the transfer function of this network? So this is nothing but the product of these two impedances. So therefore, this is equal to R into 1 by SC, right? R into 1 by SC divided by, so this is equal to 1 by SC into R plus 1 by SC, right? Plus R into, so 1 by SC into sum of all these impedances, and then R into sum of these two impedances, so R plus 1 by SC, right? So this is nothing but beta, right? This is nothing but beta. So therefore, when you take the LCM in the denominator, what do you get here? So this is R plus R is nothing but 2R plus 1 by SC. So therefore, 2 into SRC plus 1 by S square C square, right? Plus this is nothing but R into SCR, right? So R into SCR plus 1 divided by SC, right? So you can clearly see that in the denominator you have S square C square as LCM. So 1 SC will cancel. So therefore, that SC will go to the numerator. So therefore, SRC, right? SRC divided by 2 SRC plus 1 plus, look at this one. So this gets multiplied with SC. So therefore, SCR into SCR becomes S square C square R square plus SCR, right? So therefore, this is nothing but beta. Beta is nothing but SRC divided by S square R square C square plus 3 SRC plus 1, right? So therefore, I have calculated beta, right? I have calculated beta. Now I will substitute into the Barkhausen's criteria. So therefore, 1 plus R1 by R into beta is simply this one, right? Beta is simply this one. So therefore, SRC divided by S square R square C square plus 3 SRC plus 1 is equal to 1, right? This is exactly the way we have analyzed the Wien bridge oscillator in the class, right? This is exactly the similar method. Okay, this is the easiest way to analyze a oscillator, right? So therefore, this is nothing but, so this is not a Wien bridge oscillator, but the performance is similar to that of a Wien bridge oscillator. So look at this one. We have to calculate the frequency of oscillation. Also, you need to get the relationship between R1 and R, right? So therefore, tell me, substitute S equal to J omega. When you substitute S equal to J omega, you have to equate the real part and the imaginary part. So therefore, 1 plus R1 by R into J omega RC, okay, is equal to, I'll send this entire term to the other side. So therefore, minus omega square R square C square plus 1 plus 3j omega RC, right? 3j omega RC, right? So you can clearly see that in the left hand side you don't have real part, right? So therefore, the term on the left hand side is purely imaginary. So therefore, compare the imaginary term. So therefore, what is the first equation that you get? So 1 plus R1 by R, 1 plus R1 by R into omega RC is equal to 3 omega RC, right? So this is omega RC is equal to, okay, so 3, okay, this is nothing but 3 omega RC, right? So look at this one. This is equal to omega RC and omega RC will cancel, so therefore 1 plus R1 by R is equal to 3, so therefore R1 by R is equal to 2, so therefore R1 is equal to 2R, right? So therefore I got the relationship between R1 and R, right? Now what about the frequency of oscillation? You have to equate the real part. So on the left hand side there is no real part, so therefore 1 minus omega square R square C square is equal to 0, so therefore omega is equal to 1 by RC. In terms of F, it is 1 by 2 pi RC, right? F is equal to 1 by 2 pi RC, right? So this is how you calculate this particular problem. Okay, this is the frequency of oscillation, and this is the relationship between R1 and R, right? R1 and R, right? Now let us move on to the next problem. For a center tapped full wave rectifier, look at the next problem. For a center tapped full wave rectifier having both the diodes to be ideal, right? The value of N, what is N? N is nothing but the turns ratio, right? So if the input voltage, so input voltage is already given to you, the average voltage across RL. So this is a center tap full wave rectifier. The average voltage, the DC voltage across RL is nothing but 2.5 by pi. So we know that in the case of the full wave rectifier, what is the average voltage? Average voltage is nothing but 2 Vm by pi, right? So this is equal to 2.5 by pi, right? So you can clearly see that pi and pi will cancel, so therefore Vm is nothing but 2.5 by 2, which is nothing but 1.25, right? So therefore in the case of full wave rectifier, so this is nothing but Vm, this is also equal to Vm, right? So therefore across this center tap transformer, you can clearly see that this is equal to Vs, okay? This is nothing but the voltage at the secondary divided by voltage at the primary, right? Voltage at the primary is equal to N2 by N1, right? So at the secondary it is nothing but, so Vm is 1.25, so in total Vm plus Vm is nothing but 2 Vm, so therefore 2.5, right? 2.5 divided by the voltage at the primary is 10, right? So this is 10. So what is N2? N2 is simply 1, right? 1 by N1 is nothing but N, right? So therefore this is equal to N is equal to 10 by 2.5, which is nothing but 4, right? So therefore the correct answer is B, right? Therefore the correct answer is B, right? Therefore this is the correct answer, right? Now let us move on to the next problem. So this is a problem from analog electronics. Now you are given an amplifier and you are asked to calculate the voltage gain, right? So we have done similar problems, many problems in our class. So I have taught you many shortcuts to solve these type of problems, right? So look at this one. How do you calculate the voltage gain without spending much time? How do you calculate the voltage gain, right? So look at this one. Output is taken from this particular node, right? So which node is this one? This is nothing but, so this is gate, this is source, and this is a drain, right? So output is taken from drain and input. So look at this one, look at the second MOSFET, input is applied to the gate terminal, so therefore source is grounded, so therefore essentially this is common source configuration, right? Common source configuration. So common source configuration, there will be 180-degree phase shift, but in this case you are asked to, we need not bother about the phase shift, okay, because you are asked to calculate the magnitude of the voltage gain, right? Magnitude of the voltage gain. So what I will do is, I will take this point as Vx, right? I'll take this point as Vx. What I'll do is, look at this one, I'll calculate the overall voltage gain V0 by V in as V0 by X. So the normal procedure that we have learned in the class, right? So V0 by Vx multiplied by Vx by V in, right? Vx by V in, right? So therefore tell me, what is V0 by Vx? Calculate these two terms separately. What is V0 by Vx? So look at this one, input is applied to gate, output is taken from drain, source is grounded, so therefore common source configuration. So therefore look at this one, this is nothing but, since it is a common source configuration, there will be phase shift of 180 degrees. So look at this one, output is taken between drain and ground, so therefore you have RD, right? Between drain and ground you have RD divided by, so look at this one, the voltage Vx with respect to ground, in between these two nodes you have a gate and source junction, so therefore this is nothing but 1 by Gm2, right? 1 by Gm2, because this is second MOSFET, so the transconductance of second MOSFET is Gm2, right? So therefore this is nothing but minus Gm2 into Rd, right? So we have directly calculated this term, this one, the first term, right? Now what about the second term, Vx by Vin, right? So in order to calculate Vx by Vin, so look at this one, between the gate and ground you have RB, and here you have one more MOSFET where gate and drain are short circuited, right? Gate and drain are short circuited. So what is the effective resistance, what is the effective impedance looking into the source of M1? So this is nothing but 1 by Gm, right? So if he has asked to include the channel length modulation, then it would have been 1 by Gm parallel R0, right? Here he didn't give any information regarding the channel length modulation, so therefore this impedance looking into the source will be simply 1 by Gm, right? 1 by Gm, so therefore this will be, so I'll draw that portion. So look at this one, this is nothing but Rs. So since you are calculating the voltage gain, you can short circuit the capacitance, so therefore this is nothing but Rb. Okay, this is Rb, and look at this one, when you look into the source, the effective impedance is nothing but 1 by Gm, transconductance of which MOSFET? First MOSFET, so therefore M1, right? So therefore this is nothing but 1 by Gm1, right? So this node, the voltage at this node with respect to ground is nothing but Vx, right? So we have called it as Vx, right? We have called this voltage at this node with respect to ground is nothing but Vx, and this is nothing but Vin, right? So all you need to find is nothing but Vx by Vin, right? We know that the current into the gate terminal is nothing but 0, so therefore whatever current flows through this branch will flow through this branch, so therefore you can apply voltage division rule, right? Voltage division rule. So tell me, what is Vx by Vin? Vx by Vin is equal to, so look at this one, Vx by Vin. So this is equal to, Vx is equal to Vx by Vin is equal to, or Vx is equal to total voltage Vin into Rb plus 1 by Gm, right? Rb plus 1 by Gm1 divided by Rs plus Rb plus 1 by Gm1, right? So therefore you can send this V into the other side, okay? So therefore Vx by V, right? So therefore in two steps we have directly calculated the overall voltage gain. So therefore in this particular question he is just asking you to find the magnitude. So therefore the first term is nothing but Gm2, so you need not take the polarity, right, because he is asking you just the magnitude. So Gm2 into Rd multiplied by Rb plus 1 by Gm1 divided by Rs plus Rb plus 1 by Gm2, right? So therefore hardly we have taken 20 to 30 seconds, right? So this is what we have learnt in the class, right? So students who have attended my class will find this problem very simple, right? So this is a 2-mark question, the options are given to you. So this is a MCQ, so you have options given to you, so this is a correct answer, right? So this is how you solve this particular problem. Okay, now look at this one. For the given MOSFET circuit shown in figure, find the input impedance as shown in the figure. Okay, so you are asked to calculate the input impedance of this particular. Okay, input impedance, we know that this is a parameter which we find in AC analysis, right? And we know how to perform the AC analysis, right? So AC analysis, so how will you do this one? All you have to do is replace this MOSFET with the AC equivalent, right? So therefore what I'm going to do is I'll transform this network into, look at this one, what I'm going to do is I'll replace the MOSFET with the AC equivalent. So with its AC equivalent, so this is nothing but the gate terminal, this is nothing but source terminal, and this is nothing but drain terminal. You can clearly see that the drain terminal is grounded, right? So this is grounded. Okay, now between gate and source between gate and source, what is the voltage? VGS, right? And between drain and source, what we have is a voltage source, okay, voltage source, current source with magnitude Gm into VGS, right? So this is nothing but Gm into VGS. So this is nothing but 1 by j omega C1. So I'll write the impedance of the first capacitance. So capacitor impedance is nothing but 1 by j omega C1, right? So this node is connected to gate and this node is connected to ground, connected to source, right? This is source, and between source and ground what we have is another capacitor. So therefore I'll write its impedance, which is nothing but this is nothing but 1 by j omega CL, right? So I'll call this as Z1 and I'll call this as ZL, right? I'll call this as ZL. Now all you have to calculate is the input impedance. So therefore in order to calculate the input impedance, what I am going to do is I'll connect a voltage source of magnitude V which injects a current of I amperes. So all I have to calculate is this ratio V by I, right? All we have to calculate is this ratio V by I, right? So therefore look at this one, look at this one. So if this is I, okay, if this is I, obviously what will be the current flow into this branch? This will be I, right? This will also be equal to I. So what will be the current flow into this one? This will be 0 amperes because there is a open circuit here. So for current to flow, you need a closed path. So therefore the entire I will flow through this particular branch, right? Now look at this one. Between the source and ground, what you have is a impedance of ZL, and between source and ground you have a current source of magnitude GM-VGS, right? So therefore what you can do is you can redraw the circuit like this, right? So what I'm going to do is I will redraw this one. So this this voltage source I'll drag it downwards. So therefore this current source I'll drag it downwards. So therefore this is nothing but GM-VGS, right? GM-VGS. So therefore this is a circuit that we have. So I am erasing this part, right? So why did I do this? Because all I need is this ratio V by I, right? So what I'm going to do is I'll apply the source transformation here, right? I'll apply the source transformation. So when I apply source transformation here, you can clearly see that this becomes a voltage source, okay? This becomes a voltage source. So this is nothing but, so this part I'll draw it here. So this is nothing but the voltage source. The positive polarity should coincide with the arrowhead. So therefore this is positive and this is negative, and therefore this is nothing but GM VGS into ZL, right? And the impedance remains the same, right? The impedance remains the same. So therefore this is nothing but ZL, right? So therefore when you apply source transformation, this is what you get. So therefore I'll replace this with a practical voltage source, right? So practical voltage source. So this is nothing but a dependent source with the magnitude GM VGS into ZL, right? So what you will find is this current I amperes will now flow through this branch, right? So the same current is flowing through this branch. So all you have to do is apply KVL in this particular loop, right? Apply KVL in this particular loop. So I'll start with V, okay? I'll start with V. So current is flowing this direction. So whenever you apply KVL, make sure that you have marked the polarities across every element in the loop. So therefore current is flowing downwards, so plus minus, right? So current is flowing in this direction. So this I amperes will flow through this branch. So therefore current is flowing downwards. So polarity is plus and minus, right? So look at this one. V minus Z1 into I, right? V minus Z1 into I. So you are moving from higher potential to lower potential. Again voltage drop. So whenever you have voltage drop, place a negative sign. So minus GM VGS into ZL, right? GM VGS into ZL minus because you are again moving from higher potential to lower potential. So therefore I into ZL or ZL into I is equal to 0, right? So look at this one. What we require is this ratio V by I, right? V by I is what we need. So therefore what is VGS? VGS is nothing but the drop across the voltage across the capacitor. So therefore VGS is nothing but I into Z1, right? I into Z1. So therefore I am going to substitute here. So V minus Z1 into I minus GM into VGS is nothing but I into Z1 into ZL. Okay. So VGS I have written as I into Z1. So minus ZL into I is equal to 0. So from this you can clearly see that V by I is nothing but Z1 plus ZL plus GM Z1 ZL, right? So therefore Z1 is nothing but 1 by Z1 is nothing but 1 by j omega C1. Z1 is nothing but 1 by j omega C1, and ZL is nothing but 1 by j omega CL, and this is nothing but GM into 1 by j omega C1 into j omega CL is something but minus omega square C1 CL, right? So therefore this negative sign goes to the numerator, and this is one of your options, right? So this is nothing but the input impedance. Okay, this is nothing but the input impedance. So this one I have simplified this using the source transformation theorem, right? So therefore this is how you solve this particular problem. This is also a 2-mark question. Okay, so this is basically a MCQ question, so one of your options is this answer, right? So therefore now let us move on to the next question. So the data regarding this question, we are not that confident. Okay, so look at this one. In this particular question, he is asking you to calculate the power dissipation in the Zener diode. Again, I am repeating, we are not confident about the data given in the question. So he is asking you to power dissipation in the Zener diode. So the switch is closed at T is equal to 0, assuming that the switch is closed at T is equal to 0, right? So before closing the switch, the initial voltage across the capacitor is given as 10 volts, right? So it is given as 10 volts. Okay, so what happens to the what happens when switch is closed? Obviously what happens, the current will flow, okay, will start to flow from the capacitor, right? So current will start to flow from the capacitor to the rest of the circuit. So therefore look at this one, he's asking you to calculate the power dissipation across the Zener diode. So we know how to calculate the power dissipation across the Zener diode, a product of voltage and current. So therefore Vz into Iz, right? Vz into Iz. So therefore how long does the current flow when the voltage? So what happens, you can clearly see that once the switch is closed, the current will start to flow, and at one particular point the Zener diode goes into breakdown, right? So therefore what will be Iz? Iz is equal to 10 minus 5 by 10 minus 5 by 10k, which is nothing but 5 by 10k, or 5 by 10k. When it goes to numerator it becomes milli, so therefore 0.5 milli, right? The breakdown voltage is already given to you, which is nothing but 5. So 5 into 0.5 milli is nothing but 2.5 milliwatt, right? 2.5 milliwatt. Okay, so the answer to this particular question is 2.5 milliwatt, right? So we are not confident about this particular data given in this question, so we'll check, we'll rework it once we get the original question paper, right? Now look at the next question. For an NMOS in linear region with operating point, so IDS is given and VDS is given, right? And mu n Cox W by L, this information is also given to 50 microampere per volt square when VGS is equal to constant, and when VDS is equal to 1.5, then find its transconductance at the operating point, right? So initially VDS is 0.1 volt, now then it is increased to 1.5 volt, right? We maintaining VGS is equal to constant, they have increased VDS from 0.1 to 1.5. obviously the MOSFET will switch from linear region to saturation region, right? Will switch from linear region to saturation region. So you are asked to calculate the transconductance, right? You are asked to calculate the transconductance. So transconductance in saturation, so we know that, so IDS is equal to Kn by 2 into VGS minus VTN whole square. So what is the transconductance? Transconductance in saturation is nothing but GM is equal to Kn into VGS minus VTN, right? So Kn is already given to you. All you have to find is Vgs minus Vtn. There is no information regarding the Vgs and Vtn, so therefore you have to make use of the information given in the first line, right? So therefore look at this one. What did he give here? The current flowing through the MOSFET when it is operating in linear region is 5 micro, right? So in the second line they have mentioned that without changing VGS they have increased VDS. So obviously VGS in the first case and in the second case is fixed, right? And VT obviously it is constant for a MOSFET. So therefore without changing VGS, okay, so all you require is VGS minus VTN. So this difference, okay, in order to calculate the transconductance you need this difference, right? So look at this one. Using the first condition, so IDS is equal to mu n Cox W by L into VGS minus VTN minus VDS by 2 into VDS, right, into VDS. So look at this one. What is the current given? What is the current flowing through the MOSFET? So it is given as 5 microamperes. So this is equal to mu n Cox W by L is given as 50 micro, right? 50 micro. So I'll take out this unit. So therefore 5 micro is equal to 50 micro into, this is what we require. So I'll call this term as X, right? So therefore X minus VDS is 0.1. So therefore 0.1 by 2 into VDS is nothing but 0.1, right? So what is it that you get? You can clearly see that this micro and micro will cancel. So 5 10 times, right? So 10 into 0.1 is simply 1, right? So therefore 1 is equal to 10 into 0.1 is 1 into X minus 0.1 by 2. So therefore X is equal to 1 plus, I'll send it to the other side, so 1 plus 0.1 by 2, right? So therefore this is nothing but 1.05, right? So 1.05, right? 1.05. So this is nothing but VGS minus VTN, right? So take this value, substitute into this equation. Kn is already given to you, right? Kn is given as Gm is equal to Kn is nothing but 50 micro, right? 50 micro into 1.05 is your answer, right? So this take out your calculator and find out this value. So this will be the answer, right? So this is how you solve this particular problem, right? Now let us move on to the next problem. So look at the problems from SSG. Look at the problems from SSG. So read the question carefully. In a semiconductor, the concentration graph with distance x is given, then which of the following options are correct? So essentially this is a multiple select question, okay, more than one options can be correct. So read the question very carefully. So concentration of electrons is given. So in between B and C, the diffusion current is from C to B, okay. So look at this one. We have learnt in non-degenerate semiconductors, that is, if the concentration, if the doping is non-uniform, okay, if the doping is non-uniform, what happens? There will be diffusion, right? In order to cancel out this one, there will be a drift current which flows in opposite direction, okay, making the total current is equal to 0, right? We already have learned this, right? So look at this one. You can clearly see that at position C. So first we'll focus on the first two options in between B and C, okay. In between B and C, you can clearly see that the concentration of electrons at C is high when compared to the concentration of electrons. So concentration of electrons at C is greater than the concentration of electrons at B, right? So therefore what happens? The electrons will diffuse, electrons will diffuse from where to where? Electrons will diffuse from C to B, right? So electrons are diffusing from C to B, right? The current due to the diffusion of electrons, the current due to the diffusion of electrons will flow from electrons are diffusing from C to B. So therefore the current will be, the direction of current will be the opposite direction as that of the electron flow. Since the electrons are flowing from since the electrons are diffusing from C to B, the current will flow from B to C, right? The current due to this diffusion of electron will flow from B to C. So look at this one, the diffusion current is from C to B, no, right? The diffusion current is from B to C, yes, okay, the diffusion current is from B to C, okay, this is the correct answer. So this is a multiple select question, so therefore you should also look at the other two options. In between A and C, the drift current is from A to C. Now he is asking you to look at the second region, that is from between A and C. Okay, between A and C, you can clearly see that the electron concentration of electron concentration at A is less than the electron concentration at C, right? So the electron diffusion will take place from C to B, right? So therefore the current due to this diffusion, electrons are diffusing from C to B, so therefore the current due to this diffusion will flow from it is between the points A and C, right? So therefore the electrons diffuses from C to A, okay, the electrons diffuses from C to A, so therefore the current due to this diffusion will flow from A to C, right? So in order to cancel out this current, that is the drift current has to flow from, diffusion current is flowing from A to C, so therefore drift current has to flow from C to A, right? Drift current has to flow from C to A, and look at this one, the drift current flows in the direction of the E field, right? The drift current flows in the direction of E field. So if you have attended my classes, you can clearly make this out, okay? So look at this one, in between A and C, the drift current is from A to C. The drift current has to flow from C to A. Here it is A to C, so therefore option C is incorrect, right? In between A and C, the electric field is from C to A. Okay, look at this one. We know just now I have concluded that if the drift current is from C to A, obviously the drift current flows in the direction of E field, right? So induced E field, this induced E field is due to the non-uniform doping, right? This induced E field is due to the non-uniform doping. So therefore, look at this one, E field should be in the direction C to A, right? So therefore this is also correct, right? Option D is also correct. So therefore in this particular case, option B and D are correct. Okay, options B and D are correct. Options B and D are correct. Okay, now let us move on to the next problem. Okay, this is also a bit tricky. Okay, read the question carefully. P substrate, okay, P substrate MOS capacitor with the oxide thickness, so Tox is equal to, 100 nanometers, okay, oxide charge is equal to 10 raised to minus 8 coulomb per centimeter square, work function of metal, so Q into psi m is equal to 4.6 electron volt, okay. So relative permittivity of oxide is nothing but 4, right? So this is a printing mistake, so this is 4, right? And relative permittivity is nothing but 8.85 into 10 raised to minus 14 farad per centimeter. If flat band voltage is 0, then work function of semiconductor, right? So flat band voltage, so the measured flat band voltage is 0, okay, the measured flat band voltage is 0. So here is given that there is oxide charge, right? So therefore we have already done this model problem, okay, in the class. So therefore look at this one, what is the relationship that I have taught in the class? So this is equal to Qox by Cox is equal to the flat band voltage, actual flat band, okay, actual flat band voltage minus measured flat band voltage, So how did we derive this? We have in detail covered this in our class, okay. So look at this one, measured flat band voltage, what is he given? If the flat band voltage is equal to 0, so this is given as 0, right? So actual flat band, so this is nothing but phi ms, right? So this is Qox by Cox, right? So positive charge, okay, this is positive charge because oxide charge is given as 10 raised to minus 8 coulomb per centimeter square, right? So Q ox by C ox is equal to phi m minus phi s, right? All you have to calculate is phi s, so phi s is equal to phi m minus Q ox by C ox, right? So phi m is nothing but 4.6 volt, right? So this Q into psi m is nothing but 4.6 electron volt, so psi m is equal to 4.6 volt, right? So therefore this is 4.6 minus Q ox, oxide charge is nothing but 10 raised to minus 8, right? 10 raised to minus 8 by C ox. C ox, how do you calculate C ox? C ox is nothing but this is nothing but epsilon ox by T ox, right? So epsilon ox is nothing but relative permittivity is given as 4 multiplied by 8 into 8.54 into 10 raised to minus 14 divided by T ox. T ox, how much is given? So 100 nanometers. Listen, be careful. It is given in meters, right? It is given in meters. So therefore, this is nothing but 100 into 10 raised to minus 9 meters. You have to convert it into centimeters. So therefore, this becomes 10 raised to minus 7 centimeters, right? So just substitute everything into this equation. So calculate the value of C ox, substitute C ox into this equation. Okay, when you solve this one, it comes out as 4.3 volt, right? 4.3 volt, right? So this is how you solve this particular problem. Okay, so this is a problem based on the trapped charges, okay, which we have addressed in the class. Okay, so this is how you solve this particular problem. Now let us move on to the next one. Look at this one. In a solar cell, voltage corresponding to the maximum voltage point. So maximum voltage point, so already he has given the hint, maximum voltage point is nothing but the open circuit voltage, right? Open circuit voltage is 0.3 volt, okay? And photocurrent is given as 1 milliampere, thermal voltage is 30 millivolts. Find the reverse saturation current, right? So what happens at open circuit voltage? So I, what is the equation for the current? So I equal to I naught or Is into e raised to V by eta Vt or Vt minus 1 minus I photo, right? So what happens when V is equal to open circuit voltage, then I is equal to 0. So therefore, so from this equation, so Is into e raised to Voc by Vt minus 1 is equal to I photo, right? So therefore what you have to calculate is this reverse saturation current. So Is is equal to photocurrent divided by e raised to Voc divided by Vt minus 1, right? So this is the equation. So photocurrent is already given to you, which is nothing but, what is a photocurrent? 1 milliampere, right? So this is 1 milliampere divided by open circuit voltage 0.3 volts. So this I can write it as 300 millivolt because this is 30 millivolts, so I can cancel out them. So therefore this is nothing but 300 milli divided by 30 milli minus 1, right? So when you solve this one, it comes out as a value, so which I have already calculated. So this value comes out as 45.30 nano amperes, right? 45.30 nano amperes. I think the answer is asked in nano amperes, right? So therefore 45.30 nano amperes, right? So this is how you solve this particular problem. Okay, now let us look at the next problem, which is a problem from complex variables. Okay, which is a problem from complex variables. So you can clearly see that where are your poles located? You have 3 poles, 2 of them are at origin, right, and the other one is at 2, right? So how do you solve this one? And all the poles are within the region, within the given region. So magnitude of Z is equal to 3. You can clearly see that all the poles are within the region. So therefore all you have to solve is using the Cauchy's theorem. So therefore look at this one, 2 pi I into residue of due to pole 0, okay, pole 0 plus, so you have a pole at 0, right, residue due to the pole 0 and residue due to the pole 2, right? So when you solve this one, the answer to this comes out as 2 pi I into minus pi by 2, right? 2 pi into minus pi by 2. So therefore 2 and 2 will cancel. So therefore what is the resultant answer? Minus I pi square, right? Minus I pi square, right? So this is a problem from complex variables. Okay, so you just have to calculate the residue due to these poles, because these poles are within the region, right? So therefore you have to find the residues due to this pole and residue due to the second pole, okay, which is at z equal to 2, right? Now let us move on to the next one. So look at this one. Look at this particular problem. So a vector field is given, and also he has mentioned that look at this one, integral f bar dot dr is independent of the path, right? It is independent of the path. So essentially f bar should be a conservative field, right? F bar should be a conservative field, right? And for conservative field, what is the condition for checking whether the field is conservative? So del cross f bar is equal to 0. How did I arrive at this conclusion? Because he has mentioned that, so this integral is independent of the path, which we have learnt in electrostatics, right? Which we have learnt in electrostatics. So therefore look at this one, f bar is essentially a conservative field, and the condition for conservative field is nothing but del cross f is equal to 0, right? So if f bar is a conservative field, obviously a scalar function, okay, a scalar function will exist. So therefore f bar is equal to del, that is gradient of a scalar function, right? Gradient of a scalar function. So therefore option B is correct, okay, option B is correct. So look at this one, look at the last option, that is close integral f bar dot dr bar, essentially it should be equal to 0, right? So in a conservative field, this integral over a closed contour will be obviously equal to 0, because look at this one, using Stokes theorem we know that integral f bar dot dl is nothing but, so double integral del cross f bar dot ds, right? So therefore since del cross f bar is equal to 0, so since this is equal to 0, this will also be equal to 0, right? So therefore option D is also correct, okay, option D is also correct, and from this one you can directly make this one, right, this option, because when you take the curl, when you find the curl operation, you will get this condition, right, this condition. So therefore this is the correct answer. So therefore B, C and D all are correct. So this cannot be true, right, because it is a conservative field, right? It is a conservative field, this need not be equal to 0, right? So this is not correct, right? So therefore B, C, D are the correct options, right? Now let us move on to the next question. Look at the next question. Dou rho by dou t is given as, if I send this to the other side, this is nothing but minus of del dot rho u, okay? So this is what is given. So what is the extra information that is given to you? Rho is a scalar function and u is a vector function, right? It is a vector function. Then which of the options are true, right? So if you look at the first option, on either side you have integral with respect to volume. So therefore if I integrate on either sides with respect to volume, what is it that I get? So this is nothing but triple integral dou v, right? Triple integral dou v, right? So therefore this is nothing but the first equation, so which I get by integrating on both sides with respect to, okay, volume, right? So therefore the first answer, the first option is correct, right? The first option is correct, right? Now look at this one. If you look at this one, this is nothing but just by looking at this term I can apply the Gauss divergence theorem. So Gauss divergence theorem, so this is nothing but the triple integral del dot rho v. So therefore it should be, look at this one, so this should be close integral rho v rho u bar, okay, rho u bar dot ds, right? Rho u bar dot ds, close integral rho u bar dot ds is equal to, so this should be equal to, look at this one, so close integral del dot rho u dv, right? So therefore which is the correct answer? So look at this one, this is nothing but, so since this is equal to this term, so therefore this is also equal to this term, right? So therefore I will take this negative sign to this side, so therefore this is equal to, because you have a negative sign, obviously there should be a negative sign here, so therefore this two terms should also be equal, so therefore option C is also correct, right? Option C is also correct. All I have done is I have applied Gauss divergence theorem, right? Gauss divergence theorem, right? Problem number 33 is a multiple select question, so you have two answers, A and C are correct answers, right? Now let us move on to the next question. So this is also incomplete, okay? So the idea of this question is to calculate the eigenvectors, okay? Eigenvectors. So all you have to do is first you have to calculate the eigenvalues. How do you calculate eigenvalues? Take the characteristic equation, right? So therefore take the character, so this is nothing but this is equal to 0, okay? So therefore determinant of A minus lambda I, so A is nothing but this one, so A minus lambda I, so therefore 1 minus lambda, okay? 1 minus lambda minus, sorry, this is 0 and this is 2, right? This is 2 and this is 1 minus lambda, determinant is equal to 0, so therefore lambda minus 1 whole square minus, so this is something but k, right? This is k, I made a mistake here, so this is something but k, right? So A minus lambda, right? So therefore this is A minus lambda, okay? So this minus 2k is equal to 0. So what are the eigenvalues that you get? So this is nothing but lambda square minus 2 lambda plus 1 minus 2k is equal to 0. So therefore what is it that you get? Eigenvalues is equal to minus b, 2 plus or minus b square, 4 minus 4ac, right? 4 into 1 minus 2k divided by 2, right? Divided by 2. So therefore if I take 4 and 4 common from both these terms, and when it comes to the outside the square root, it becomes 1 plus or minus, because 2 by 2 is nothing but 1, and here also you have 2, so therefore 2 by 2 is 1. So therefore 1 minus 2k is simply 2k, right? So 2k, right? So therefore you have eigenvalues, okay? Eigenvalues, you are asked to calculate the eigenvectors, right? So therefore how do you calculate eigenvectors? So this is a condition, Ax is equal to lambda x, lambda you got, right? A is already known to you, right? So use this equation and select the appropriate options, right? Select the correct options. So options are not given to you, okay? This is also a multiple select question, okay? This is also a multiple select question, so therefore options are not available to us at the moment, right? So once we get the original question paper, we'll solve this one, right? Now look at the next question. What is he asking to calculate? The following vectors do not form basis for any vector space, right? So for the vectors to be basis vectors, they have to be linearly independent, right? They have to be, for a set of vectors to be basis vectors of a vector space, they should be linearly independent. Here they have told that the vectors do not form basis, so therefore these vectors are linearly dependent, right? So these vectors are linearly dependent in the sense that the determinant of these vectors is equal to 0, right? This vectors is equal to 0, so therefore this is equal to 2 minus 3 a, 3 minus 1 3, 1 minus 5 7. So therefore when you calculate the value of this determinant, the value of this determinant will come out as 5, right? So the value of a will come out as 5, right? When you calculate the value of this determinant and equate it to 0, the value of a comes out as 5, right? Now let us move on to the next problem. Look at this one. If y of t is equal to the complementary function of a differential equation is given to you, he is asking you to find the differential equation, right? Look at the solution, look at the complementary function. Y of t is equal to at plus b into e raised to minus t, right? So looking at the solution, I can clearly make out that this will be the solution when you have repeated roots, right? When you have repeated roots. So look at this one. So if you have repeated roots, so what will be the solution? Solution will be of this form. So therefore roots, look at this equation and tell me what will be the roots of the differential equation. So this is nothing but the roots, you can clearly see that this is nothing but minus 2, right? So t is equal to, or roots, we have the repeated roots as -2, right, -2. So therefore d plus 2 whole square is equal to 0. So therefore d square plus 4d plus 4 is equal to 0. So look at this one. How do you calculate complementary function? You have to set the right hand side to 0. So therefore right hand side to 0. So therefore now check this equation with the options. You can clearly see that option B is the correct answer, because d square by dx square, you can write it as d square plus 4d plus 4 into y, okay, into y is equal to 0, right. So this is nothing but the correct answer, right. This is nothing but the correct answer. So how did I arrive at this conclusion? Because I know that this is the general equation when that you get when you have repeated roots, okay, repeated roots. So therefore D is the correct answer, right. Now let us move on to the next problem. Okay, this is nothing but the aptitude questions. Look at this one. 5 years ago, sons and fathers age ratio. So sons and fathers age ratio was 1:4 5 years ago. So if the present age of son is S and father is F, 5 years ago the ratio was 1:4. So therefore S minus 5 divided by F minus 5 is equal to 1/4, right, 1/4. And similarly after 5 years, so this is before 5 years, 5 years ago, this is the case 5 years ago, and after 5 years. So therefore S plus 5 divided by F plus 5 is equal to 2/5, right. So this is equation number 1 and this is equation number 2, okay. And when you solve these two equations, you have two equations and two unknowns. The son's age will come out as 15 and father's age will come out as 45, right. Father's age will come out as 45 years. What is he asking? Find the father's age at the birth of the son, right. So therefore you have to subtract 45 minus 15, which is nothing but 30 years, right. So therefore the father's age at the birth of the son is simply 30 years, right, simply 30 years, right. Now let us move on to the next question. For the given rectangular sheet, he has given two conditions. Fold the paper parallel to longer side 2 times, okay. So this is the parallel to longer side in the sense, so this is 24, look at this one, this is 24 centimeter, okay. So condition number 1, so this is 24 centimeters, okay, and this is 16 centimeters, okay. All you have to do is fold parallel to longer side 2 times, okay. So parallel to longer side, so this is parallel to longer side. So therefore when you fold it once, what happens? So after folding it once, it becomes, look at this one, when you fold it once, what happens to this length? It becomes 8, right, it becomes 8 and this remains as it is, right. So this is nothing but 24 itself, right. So you have to fold it 2 times. So when you fold it once again, right, so this length remains the same, this becomes half, right, this becomes half. So therefore this becomes half of 8 is nothing but 4, right, half of 8 is nothing but 4, okay. So this is the first case. Now second case is nothing but, so this is nothing but the second case. Fold the paper parallel to the smaller side 2 times, right. So parallel to the smaller side, so this is nothing but the parallel to the smaller side. So therefore when you fold the paper parallel to the smaller side, so this becomes, so 12 becomes 24 becomes 12, okay, this becomes 12. What about this length? This length remains as it is, right. Now this is what you get when you fold it once. You have to fold it twice, right. So therefore this is what you get when you fold it twice. So therefore this is equal to 6, okay, and this distance, this length remains the same, right. All you have to do is, look at this one, you have to take the ratio of perimeter of condition 1 to condition 2. So what is the perimeter of this one? So 2 into 24 plus 4 is nothing but 28, right, perimeter. So this complete, right, so this complete length, so 24 plus 4 is 8. So perimeter, you have to take this and this distance as well. So therefore 2 into 28 divided by 2 into what is the perimeter of this one? So this is 6 plus 16 is nothing but 22, right? So therefore you have to get this ratio. So therefore 14 by 11, right? 14 by 11. Okay, so the answer to this particular question is 14 by 11, right? So this is based on the data given to us. Okay, we are not sure about the content. Okay, so this is based on this data. Okay, this is based on this data, exact data. We don't know. Once we get the original question paper, we'll solve this question. Okay, so based on the given data, this is the answer, right? Now let us move on to the next question. So this is also a aptitude question. So look at this one. 1 by log x base 2. So 1 by log x base 2. 1 by log x base 2, I can write it as log to the base 10 divided by log x to the base 10. Right. So therefore similarly I can write the other two terms as other two terms. How can I write other two terms? Look at this one. This I can write it as log 3 base 10 divided by log x base 10. Okay, so log 4 base 10 divided by log x base 10. Okay, this is equal to 1, right? So LCM is nothing but log x base 10, right? So this, what happens, you can take, look at this one, log a plus log a plus log b plus log c. How can you write? So log a b c, right? So therefore 2 into 3 into 4, 6 into 4 is nothing but 24 base 10 is equal to 1, right? So log 24 base 10 is equal to log x base 10. So therefore x is equal to 24, right? So therefore the correct answer is C, right? Therefore the correct answer is C, right? Now look at the next question. What is he asking to calculate? Highest prime factor. So highest prime factor, 3 raised to 199 minus 3 raised to 196. So if I take 3 raised to 196 common, so what are you left with? 3 raised to 3 minus 1, right? So this is nothing but 3 raised to 196 into 27 minus 1 is nothing but 26. So 26 I can write it as 2 into 13. So therefore you can clearly see that we have factorized this number in terms of prime numbers. So what is the highest prime factor? You can clearly see that the highest prime factor is 13. Therefore the correct answer is C, right? Therefore the correct answer is C, right? Now look at this question. Look at this question. What is he asking to calculate? Okay, this is basically a condition for Nyquist condition for zero intersymbol interference, which we have clearly derived in the class. Okay, this is nothing but a question based on the condition for zero intersymbol interference, which we have clearly derived in the class. So therefore look at the options and tell me which one is a correct answer. So here it should be F, right? So here there is a printing mistake. It should be F, right? It should be F, 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 right? So therefore this one. So what is the condition actually? The condition for the zero intersymbol interference. So m is equal to minus infinity to plus infinity x of f minus m into fs is equal to t, right? So this is nothing but, okay, this is nothing but the condition for intersymbol interference. So with the data that we have, I think C is the correct answer, right? C is the correct answer, right? Now let us move on to the next question. Look at this one. Random process signal x of t is given as x of t. X of t is given as a cos 2 pi f naught t plus theta, right? Where a and theta, this is theta, right? This is theta, are independent, right? And a is uniformly distributed in minus 2 to 2 and theta is uniformly distributed 0 to 2 pi, right? So the autocorrelation function of this random process is already given to you. So the autocorrelation function of the random process is nothing but Rx of tau is nothing but 2 by 3 cos 2 pi f naught into tau, right? So so it is a 8-bit quantizer, right? So it is a 8-bit mid-rise quantizer, so he's asking you to find the signal to quantization noise ratio, right? Signal to quantization noise ratio. So therefore this is nothing but the signal power to the quantization noise power, okay? Signal power to quantization noise power, okay? Signal power to quantization noise power. So signal power, how do you get the signal power? So the signal is a random process, so how do you get the signal power? From the autocorrelation function. We know how to calculate the signal power from the autocorrelation function, which we have learnt in the class, right? So we have learned this one. So therefore, how do you get the power? All you have to do is you have to substitute tau equal to 0. When you substitute tau equal to 0 into this one, so this is nothing but, so this is equal to expectation of x square of t, right? Expectation of x square of t, right? So this is equal to 2 by 3, right? This is nothing but the signal power, which is nothing but 2 by 3, right? Which is nothing but 2 by 3. And quantization noise power, so quantization noise power is equal to delta square by 12, right? So delta is nothing but Vmax minus Vmin divided by 2 raised to n, right? So what is Vmax and Vmin? Look at the amplitude of the input random process. It is uniformly distributed in the interval minus 2 to 2. So maximum value is 2 and minimum value is minus 2, right? So therefore this is nothing but 2 minus of minus 2 divided by 2 raised to, he has given that it is a 8-bit quantizer, so therefore n is nothing but 8, right? So therefore 4 by 2 raised to 8, right? So substitute all these things into this equation and calculate the signal to quantization noise ratio. I think he is asking you to find the signal to quantization noise ratio in dB, right? So when you calculate this one, the answer to this one, which we have already calculated, so it comes out as 45.15 dB, right? 45.15 dB, right? So all you have to do is, so signal to noise ratio, this is nothing but 2 by 3 divided by, so this is delta, okay, delta. So therefore this is equal to 4 by 2 raised to 8 is something but 2 square by 2 raised to 8 is something but 1 by 2 raised to 6, right? So 1 by 2 raised to 6 whole square divided by 12, right? So simplify this one and find it in dB. So 10 log this one, right? So it comes out as 45.15 dB, right? Now let us move on to the next question. Look at this one. Okay, this also we have directly derived. Okay, we had derived in the class. So therefore look at this one. A white Gaussian noise is passed through a first order RC low pass filter, right? RC low pass filter. So therefore what is he asking? It produces output n of t, and at a particular time t equal to tk, the variance of the output noise, okay, the variance of the output noise, okay, variance of the output noise in the sense that he is asking you to calculate the power, okay, power present in the output noise, which we already know. Look at this one. This is the autocorrelation function, okay, this is the autocorrelation function at tau is equal to 0, which is nothing but n naught by 4 RC. I hope you remember this one. When a white Gaussian noise is passed through a first order low pass filter, what is the autocorrelation function? Autocorrelation function is nothing but n naught by 4 RC into e raised to minus tau by RC, right? So this is nothing but the autocorrelation function. So from autocorrelation function, how do you calculate? Look at this one. The mean input, the mean of the white Gaussian noise is nothing but 0, right? So therefore this is already given to you, which is nothing but 0. We have already derived this in class. So therefore from this, how do you calculate the variance? Variance is nothing but substitute tau equal to 0 into this equation. So therefore n naught by 4 RC is the variance, right? So variance is simply, look at this one, variance is simply expectation of x square minus expectation of x whole square, right? So look at this one, the output, what will be the noise of the output, mean of the output noise, because since the mean of the input is 0, mean of the output will also be equal to 0. So therefore, look at this one. So sigma square is equal to expectation of x square. So expectation of x square, this is equal to 0. So expectation of x square is nothing but r of 0, right? So therefore, since we already know the autocorrelation function, okay, autocorrelation function, so n naught by 4rc into this term. So therefore, substitute tau is equal to 0. When you substitute tau is equal to 0, it becomes n naught by 4rc, right? So therefore, the answer is B, right? The answer is B. Now, a source transmits symbols from alphabet of size 16. The maximum achievable entropy is nothing but log L base 2, right? So therefore, what is the size of the alphabet? 16. So therefore, log 16 base 2 or log 2 raised to 4 base 2, which is nothing but 4 bits per symbol, right? 4 bits per symbol. The entropy is 4 bits per symbol. The answer is 4 bits per symbol, right? Now let us look at the next question. Look at the next question. Suppose x and y are two identically independent and uncorrelated random variables distributed uniformly in 0 to 1. The probability that x is greater than or equal to y, right? So what I am going to do is I will take this y to the other side. So therefore, x minus y is greater than or equal to 0, right? What I am going to do is I will define a new random variable z is equal to x minus y, right? So we have looked at this special case, okay? We have already discussed this in the class. Whenever you have independent and identically distributed random variables, whenever you have independent and identically distributed random variables, so if you have a function like this, so look at this one, a new random variable is been defined using these two random variables. So therefore, z is equal to x minus y, right? So how do you calculate the PDF of the new random variable? So PDF of the new random variable is nothing but the convolution, right? Convolution of the PDFs of these two random variables. So fx of x convolved, right? Here what you have is something but, look at this one, minus y, right? So therefore, so f of minus y, right? F of minus y. So therefore, look at this one, x is uniformly distributed in the range 0 to 1 and y is also uniformly distributed in the range 0 to 1, right? So if you draw the PDF of random variable x, it is nothing but fx of x is equal to 0 to 1, right? 0 to 1, the PDF. So area under the PDF should be equal to 1. So therefore, this should be equal to 1, right? So if this is what we have is y, right? What we require is minus y. So therefore, look at this one. It is distributed in the interval minus 1 to 1 and the amplitude should be 1, right? So therefore, this is something but the PDF of f of minus y, right? So when you convolve both this one, so you can clearly see that you have two rect functions of equal magnitude, right? Two rect functions of equal magnitude. So therefore, when you convolve them, what you get is a triangle, right? What you get is a triangle extending from minus 1 to 1, right? Minus 1 to 1. And what will be the slope? Slope will be the product of these two amplitudes. So 1 into 1 will be 1. So therefore, you know the slope, you know this point. So therefore, this point will be equal to 1, right? So therefore, this is nothing but the PDF of the new random variable z, right? So all you require is probability that z is greater than or equal to 0, right? So you can clearly see that all you require is this area, right? Probability that z is greater than or equal to 0. So therefore, what is this area? So half into base is nothing but 1, height is nothing but 1. So therefore, 0.5, right? So this probability is something but 0.5, right? So this is how you solve this particular problem, right? Now this is a very simple problem. So this is a problem from analog communication. So look at this one. The time domain equation of analog amplitude modulation is given to you, right? So when you compare it with the standard form, so A is simply AC and B is simply AC into mu by 2, right? Also he has given that the the carrier power is 50 watt. So PC is equal to carrier power is equal to 50 watt. Ratio of sideband to the total power, that is PC into mu square by 2 divided by PC into 1 plus mu square by 2, right? So this is nothing but the sideband power to the total power, right? So this ratio is given as 1 by 9, right? This ratio is given as 1 by 9. So from this equation, from this information, you can easily calculate the value of the carrier amplitude, which is nothing but AC square. Carrier power is nothing but AC square by 2R. Since the value of R is not given, so I will take it as 1. So therefore AC square by 2 is equal to 50. So therefore AC square is equal to 100. So therefore AC is equal to 10, right? AC is equal to 10. So what you require is the value of B, right? So B, in order to calculate B, you need AC as well as mu, right? So look at this one. This is PC and PC will cancel. So therefore mu square by 2 plus mu square is equal to 1 by 9, right? So therefore 9 into mu square is equal to 2 plus mu square. So therefore 8 mu square is equal to 2. So therefore mu square is equal to 1 by 4 and mu is equal to 1 by 2. Right. So now you know the value of AC. AC is nothing but 10 and mu is something but 1 by 2. So therefore 2 into, already a 2 is there in the denominator. So 10 into 1 by 4, which is nothing but 5 by 2, which is equal to 2.5, right, which is equal to 2.5. The answer to this question is 2.5, right. Now the next question, look at this one. For a priority encoder, so now we have questions from the digital electronics. Look at this one. For a priority encoder with priorities of D3, D2, D1 and D0 in descending order with outputs 0, 0, 0, 1, 1, 0 and 1, 1 respectively. Output is AB, find the find the Boolean function. Okay, he is asking you to find the Boolean function for the output B, right. So therefore look at this one. This is the inputs of a priority encoder D3, D2, D1 and D0, right. So this is something but the inputs of priority encoder and the outputs is something but A and B, right. So look at this one. So this have these inputs have priorities in the descending order, right. So look at this one. When the input is 1, okay, when D3 input is high, right. So irrespective of the other inputs, what will be, so if this is high irrespective of the other inputs, so what will be the output? Output will be equal to, with the corresponding outputs 0, 0, right, with the corresponding outputs 0 and 0, right. And what about this one? What about this one? Look at this one. When D2 is 1 and irrespective of the other inputs, and when D3 is equal to 0, what will be the output? So look at the corresponding output. This is given as 0, 1, right. So we'll go with the data that is given in the question. Okay, we'll go with the data that is given in the question. Okay, I hope this data is correct. So this is 1, okay. So these inputs have priority in the descending order and with the outputs given to you. And what about this one? So when D1 is high, okay, irrespective of the input given to D0, what will be the output? So output is given as 1, 0, right. And similarly this is 0, 0, 0, 1, right. So therefore this is nothing but 1, 1. Okay, this is the truth table that we get from the given data, right. So I am not sure about the data given in the question. So this is based on the information given in the question, right. So therefore this is you are asked to calculate the Boolean function for the output B, right. So therefore output B, so therefore I'll pick these two cases. So therefore this are the two instances when B is equal to, B is high. So therefore B is high when you have this combination, right, when you have this combination 0, 1, x, x, right, and 0, 0, 0, 1, right. So therefore what I am going to do is I'll draw the K map, right. I'll draw the K map. So with this as the variable, so therefore this is nothing but D3, D2, okay, and this is D1 and this is D0, right. D1 and D0. This is your K map. This is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, right? So what are the entries into the K map? So look at this one. This is 0, 1, 0, 1, 0, 1, 0, 1. So this is don't care. So therefore I'll take all the possibilities. So therefore this is 0, 0, 0, 1, 1, 0 and 1 1, right? So therefore what is the decimal equivalent? So 0 1 0 0 is something but 4, this is 5, this is 6 and this is 7, right? And this is simply 1, right? This is simply 1. So therefore 1, okay, this is 1, 4 5 6 7, 4 5 6 6 7, right? So therefore group them. So therefore this is one chord and this is one pair. So therefore this is nothing but D3 bar, D2 bar, this is nothing but D3 bar, D2, right? And what about this one? This is D1 bar, D0 bar and this is D1 bar and this is D0, right? So therefore this is nothing but D3 bar, D2 plus what about this one? This is nothing but do we have any other entries into this one? This is nothing but D1 bar D0, right? D1 bar D0, and what is the common here? What is common here? This is nothing but D3 bar, right? So this is nothing but D3 bar, okay? This is something but common is something but D3 bar. So this is based on the given information, right? We are not confident about the given data. This is based on the given data, right? So this is for a priority encoder with priorities D3, D2, D1, D0 in descending order with outputs 0, 0, 0, 1, 1, 0, 1, 1 respectively. So this is what we get with the given data, right? So this question also we are not sure about, okay? This is a data given in the data which we have obtained, right? So this is how you do this one, right? Now let us move on to the next problem, which is something but a problem on multiplexer, okay? Look at this one. If the select input S is 1, then what is Y? So this must be the output Y, right? So S is set at 1, okay? S is set at 1, so obviously it selects this input, right? So this input will be connected to the output. So therefore look at this one. Initially if Y is equal to 0, so this will be 0, and look at this one. Okay, he has given that the delay of the mux is 10 nanoseconds, right? And delay of the inverter is not given to you, so therefore you can take it as 0 seconds. So therefore if this is 0, this will be equal to 1, right? So initially the output was 0, okay? Initially the output was 0. So after a delay of 10 nanoseconds, which is the delay of the mux, so the output will switch to 1, right? Now what happens? So now the output is 1, so this 1 will be fed back. So therefore this is 1 and this is 0, right? So therefore you will get the output switched to 0 after a 10 nanoseconds. So therefore this keeps on repeating, right? This keeps on repeating. So every 10 nanoseconds, so therefore every 20 nanoseconds the same signal repeats every 20 nanoseconds. So therefore the time period is equal to 20 nanoseconds. So therefore the frequency will be equal to 1 by 20 nanoseconds, which is nothing but 50 megahertz, right? 50 megahertz, right? Now let us move on to the next problem. So a canonical SOP is given to you. You are asked to calculate the essential prime implicant, right? Essential prime implicant. So let us look at this one. Let us enter the data given to us into the K map, okay? So options are given to you. So tell me which is the correct answer. This is nothing but A bar, B bar, this is C bar, D bar, this is A bar B, this is AB, this is AB bar, right? So this is C bar D, this is CD and this is CD bar, right? This is 0, 1, 2, 3, 4, 5, 6, 7, okay? So did we 8, 9, 10, 11, 12, 13, 14 and 15, right? So I hope the min terms that we have got is correct. So look at this one: 0, 2, 5, 7, 8, 10, 12, 13, 14, 15, right? So you have to pick the essential prime implicants, right? So what are the groupings possible? Look at this one. What are the groupings possible? So you have a chord here, you have another chord here, right? You have another chord here. So this is also a chord, right? So this is also a chord. Also you can group them, right? So you can group this one, okay? So you can form a chord here, right? You can form a chord here. Now look at each prime implicant. So look at this one, this chord includes a min term which is not included by any other prime implicant, right? This chord includes a min term which is not included by any other prime implicant. So this has to be a essential prime implicant. Look at the min term 5 and 7. This min terms are not included by any other prime implicants, right? So therefore this is a essential prime implicant. So what is a simplified equation? So look at this one, this is B and this is D. So therefore BD is a essential prime implicant, right? What about this chord? You can clearly see that these two min terms are not included by any other prime implicant. So therefore listen, this chord, so this chord should be a essential prime implicant. So what is a simplified one? So this is B bar, okay, this is B bar and this is D bar, right? So this is D bar, so B bar and D bar, okay. Now let us check the other one, AB. Look at this one, AB, okay. Look at the min terms included in AB. So look at this one, the min terms 15 and 13 are already included in BD, right? Are already included in BD. And also look at this one, the other two min terms 12 and 14 are already included in the other prime implicant. So therefore AB is not a essential prime implicant, right? So because AB does not consist of any min term which is not included by any other prime implicant, right? So therefore BD and B bar D bar, both these chords includes min terms which is not covered by other prime implicants. So therefore BD and B bar D bar are the correct answer, right? BD and B bar D bar are the correct answer, right? So look at this one. Consider the sequential circuit. So this is a synchronous circuit because you have same clock applied to the two flip-flops. So therefore we have only one method of analyzing this one. So first you have to write the flip-flop output. So this are nothing but the present output, okay, this are nothing but the present output, and the flip-flop inputs and the next output, okay, and the next output. So look at this one, you have to get the sequence in this order, Q1 and Q0. This is Q1 Q0 flip-flop input. So this is, I'll call it as TA and this as T, okay, this as T1 and this as T0, right? So T1 and T0, okay. What is T1? T1 is nothing but, look at this one, T1 is nothing but the OR operation. The input to T1 is nothing but the OR operation between Q0 complement and Q1, right? So therefore Q0 complement and or Q1, right? So OR operation between Q0 complement and Q1, right? And what about T0? T0 is nothing but Q1 input to the OR gate is Q1 and the other one is Q0, right? Q0, right? So this is the next output, which is, I'll represent it with a different color. So therefore this is Q1 and Q0, right? So first I'll start with 0 0. I'll start with 0 and 0. Tell me what will be the inputs. Inputs will be, so since Q0 we have Q0 complement, so Q0 complement is nothing but 1, so therefore this should be 1. So Q1 or Q0 is nothing but 0, right? So therefore input to the T flip-flop is 1, so therefore output will toggle. So therefore earlier it was 0, so it will toggle to 1, right? This is 0, so same output will continue, so therefore this is equal to 0. So when the initial state is 0, 0, 0, the next state will be 1, 0. So in how many options do you find this sequence? 0, 0 to 1, 0, 0, 0 to 0, 1. So this is not correct. 0, 0 to 1, 0. Okay, 0, 0 to 0. Okay, in this state you don't have 0, 0. Okay, let us see. Let us see. Okay, before eliminating option D, we'll once again check that once we take this as the present input, that is 1, 0. If 1, 0 is the present input, present output. So tell me what will be the present inputs. So Q naught complement. So Q naught complement is 1. So therefore this is 1. Okay, this is 1 because Q naught is 0, Q naught complement will be 1, and what about this one? This will also be equal to 1. So therefore both the inputs to the flip flop are inputs to both the flip flops are 1. So therefore outputs will toggle. So therefore this is 0, 1, right? So therefore the next sequence will be 0, 1, right? 0, 1. You can clearly see that this is what happens in option B, right? Option B, 0, 0, 1, 0, 0, 1, and obviously, so look at this one, this is 0, 0, 1, 0, 0, 1, and once again check them. So this is 0, 1. If I select 0, 1 as the present output, so what about this one? Q naught complement is 0 and Q1 is 0, so therefore this is 0, right? What about this one? This is 1, right? So this the output remains as it is, right? And this is 1, so therefore output will toggle. So therefore obviously option B is the correct answer, right? Option B is the correct answer, right? Now let us move on to the next question. Look at this one. For the given x of t and y of t, okay, x of t and y of t. So this is x of t and this is y of t. He is asking you to find y of f in terms of x of f, right? So how do you get y of t from x of t? How do you get y of t from x of t? Tell me, how do you get it? So first what I'll do is, first I will perform time scaling, that is, this is x of t. If I scale by a factor of 1 by 4, right? So what happens? It expands in time, right? It expands in time, right? So therefore this becomes minus 4 and this becomes minus 2, right? This becomes minus 2, right? This becomes minus 2 and this becomes, okay, so this is 0, so this is simply minus 1, right? So if I multiply, if I amplitude scale it, what is it that I get? So this is simply minus 4, this is minus 2, this is 0, and this is something but minus of x of t by 4, right? So this is simply 1, right? Now what I have to do is, in order to get y of t, I have to shift the signal by 2 units. So when I shift the signal by 2 units, this is what you get here. So this is nothing but minus of x of t minus 2 by 4, right? So therefore this is nothing but your y of t, right? So this is minus 2, this is 0, and this is 2, right? So this is what you get. Now how do you apply? How do you apply the Fourier transform? Apply Fourier transform to this. So y of t, transform of y of t is nothing but capital Y of f, okay? So this is amplitude scaling, so it remains as it is. So look at this one. How do you write this one? T by 4 minus 2 by 4 is nothing but 1 by 2, right? So how do you find the transform? So x of alpha t plus beta, how did we learn in the class? First we'll assume the coefficient of t to be 1, so which is x of t plus beta, right? This is the first step, and then you scale it by you scale it by alpha, right? Alpha, right? This is nothing but alpha. Okay. So look at this one. This is nothing but, first I'll assume the coefficient. So this is nothing but x of minus of t by 4 minus 1 by 2, right? So first I'll assume the coefficient of t as 1. So therefore, what is it that you get? So this is equal to e raised to minus j 2 pi f into 1 by 2 into x of f, right? X of f. So therefore 2 and 2 will cancel, and then so this is the first step. In order to get the y of f, first you have to do this one, and then you have to scale it by alpha. So therefore, what is the scaling property? X of alpha t, what is the Fourier transform of x of alpha t? 1 by magnitude of alpha into x of f by alpha, right? So therefore, what is it that you get? So this alpha, what is the value of alpha? Alpha is nothing but 1 by 4, right? So therefore 1 by 4 is nothing but 4, right? So you have negative sign here. So e raised to minus j pi into f by alpha, right? So f by alpha is 1 by 4, so therefore this becomes 4f, right? So this also becomes f by alpha, so therefore this is also 4f, right? So therefore the correct answer is option C, right? Option C is the correct answer, right? Now this one which we have already solved, okay? Now, okay, so this are the set of questions that we had, okay? So this, with this we have completed the problems. As I told you, we don't have the complete set. These are the questions that we have obtained from our students, right? So based on the questions, I would say the paper was moderate, right? So most of the questions are directly from the previous year models, right? So nothing new except 1 or 2 questions. Most of the questions are the models which they have been asking throughout the years, okay? So I hope you have done your exam well, okay? So let's hope for the result, okay? Thank you.